Hey guys, Mr. T here, just doing another video. This one is on just Venn diagrams in general. So a Venn diagram is a way of representing a set of numbers with further groupings within the overall set. So it's like a little diagram or a graph to represent sets of things. Alright, so some of the features of a Venn diagram are the universal set, usually given the letter U. That's the overall set of numbers. Basically everything that you're talking about in the situation. And it's represented by U. You draw it as a rectangle, as in the graph, okay? Now sets. Sets are groupings of numbers within the universal set. So within everything there might be smaller groups of numbers. And you represent these with circles inside the universal set. So inside the rectangle, you're going to have circles inside that represents a smaller group of those numbers that were in everything. These are given the letters of the alphabet, except for U. So if we have an example here, let's say my U, my universal set, was the numbers 1, 2, 3, 4, 5, 6, 7, 8, and 9. And A is a subset of the numbers in the universal set 1, 4, and 8. How do I represent that? Well, I've already said that a Venn diagram consists of, that crack in my screen makes it difficult to draw, it consists of a rectangle that represents the universal set. And we're told that this has a subset A. So let's draw those. So A is a set within the universal set represented by the circle. Now if we have a close look at this, we notice that U and A both contain 1, U and A both contain 4, and U and A both contain 8. So anything I draw, any numbers that I write in A are in U as well. So we need to be careful that we represent these sets in the universal set correctly, because 1, 4, and 8 are in A as well as U. So I can confidently write 1, 4, and 8 in A because it's within the set A. And that's already in U. So how do I represent the remaining numbers? Well, I just draw them outside of the circle. So 2, 3, 5, 6, 7, and 9. Okay? So that is an example of a Venn diagram with only one set inside. Obviously they get more complicated, but that's what these videos and the practice exercises are there to help you with, so you get better at understanding them. So when you're dealing with Venn diagrams, there's a bit of terminology you need to be aware of. There's several terms you need to be aware of when dealing with Venn diagrams. So the first one is complement. Okay, complement of a set. So if I had a set A and I put a dash on it, I'm talking about the complement of the set A. The complement of a set, for example, set A is going to be A dash, and this represents the region outside the circle of A. So here I've got a Venn diagram, that's the universal set, the rectangle. I've got set A in the middle. If I was to represent the complement of set A, which is A dash, what does that represent? That represents everything in the set that is not A. So it's the area of the rectangle around the circle representing A. Okay? So that's the complement of A. Subsets. So what is a subset? Well, firstly, you represent a subset with A. It's sort of like a U side on. It's not a C. It looks like a capital U side on, and then a line underneath. B. What does this represent? A is a subset of B. So what does that mean? A subset is a set within another set. So basically a circle within another circle. How do I represent that? A with that symbol, B. That tells you that A is a set within the set B. So every element of A is also going to be an element of B. And so in your Venn diagram, this is going to be the circle of A inside the circle of B. So that's the situation we've got here. We've got the universal set we've got set B as that larger circle, we've got set A within B, and if I want to represent the subset A within B, that would be here, A subset of B is a small circle within B. The intersection of a set is the next term. That's represented with the A and the upside down capital UB. The intersection of A and B is the region where the sets A and B overlap each other. So they are the elements that exist in both A and B at the same time. So I have the universal set. We've got two sets, A and B, in the middle. That is A. That is B. Where do they overlap? This sort of oval in the center is where they both overlap. So anything in there is within set A and B at the exact same time. Whereas here, this section here, it's only in set A. This section here is only in set B. This is where A and B intersect, where the elements are in both. So that is A intersection B. Okay? Union is another term that you might need to be aware of. Slightly different to intersection. Union of A and B is represented with the A. It almost looks like a capital U. B. The union is the region encompassed by both A and B and where they overlap. So the union of A and B are the elements that are in A, B, and both at the same time. So that's different to an intersection because here you have the universal set. Here you have the two sets A and B. The union of A and B is everything that's in A, everything that's in B, and everything that's in both at the same time. So if I could color that in, let's see if I can color it in with this highlighter function. That's A, that's B, this is the intersection of A and B, so that, everything that I just colored in, represents the union of A and B, which is A union B. Disjoint, two sets are disjointed if they exist in the same universal set but they do not overlap. So there are no elements in A that exist in B. So this is just a fancy word for saying that the two sets don't touch each other or don't overlap. So you've got the universal set here. You do have two sets within the universal set, but you can see A and B, they don't overlap each other. So they're just disjointed. Right, on to an example. Let the universal set be 1, 2, 3, so the numbers 1 to 8. Draw a Venn diagram to represent the set A and the set B. So there's going to be two circles in this rectangle. There's going to be set numbers in both. The numbers 1 to 8 need to be within the rectangle. But the numbers 1, 3, 4, and 6 need to be in A. The numbers 2, 3, 6, and 8 need to be in B. So if I think ahead, I don't need to modify anything. I need to look if there's any same elements in both of these sets. And there are. There's 3. 3 is in both A and B. And 6 is in both A and B. So what does that mean? In the overlap of A, well, there's going to be an overlap first off, because there's two identical elements. And secondly, within that overlap, there's going to be 3 and 6. So I can start drawing it now without having to try to modify it after the fact and being messy. So that's the universal set. I've got a set A, and I've got a set B. That's A and that's B. And because I I thought ahead, I know 3 and 6 are in the overlap because they're in both A and B. And now I can look at just A. A contains 1 and 4. And B contains 2 and 8. So let's just check that we've got everything. We've got 1, 3 in the overlap, 4, 6 in the overlap, 2, 3 in the overlap, 6 in the overlap, and 8. But that's funny because I've got 8 numbers. 1, 2, 3, 4, 5, 6, 7, 8. Let's just check. I've got 8 numbers. 1, 2, 3, 4. I don't have a 5 and I don't have a 7. So what does that mean? Well, there's a bike coming past. What does that mean? That just means that 5 and 7 are not within the 2 sets. And we can confirm that because if you look at the 2 sets, A doesn't have 5 in it or 7, and B doesn't have 5 or 7 in it either. So that's an example of dealing with Venn diagrams and terminology that you should understand about Venn diagrams. Hopefully that helps you out, and I'll see you in the next video.